In today's video, I'm going to be answering this Chemistry Paper 2 Edexcel 9-1 paper, and it's a specimen paper, and we're doing a complete walkthrough, so I'm going to write in all the answers too. This question is about changes to the Earth's atmosphere. Which of the following is a correct statement about the relative amounts of carbon dioxide and oxygen in the Earth's early atmosphere? Hopefully you know that the Earth's early atmosphere contained lots of volcanoes, so that means that lots of CO2 was produced, and there weren't any plants releasing oxygen in photosynthesis, so oxygen levels were low. I like to try and work out the answer before I've seen the options, because then it makes it more straightforward to actually pick out the correct answer. So A, large amount of carbon dioxide and large amount of oxygen. No, that disagrees with what I just said. B, large amount of carbon dioxide and small amount of oxygen. Yes, that's literally what I just said, so that's why B is the correct answer here. Obviously, feel free to look at C and D, but you'll see that they argue with my notes that I made. B, several processes change the composition of the Earth's atmosphere. Describe how the composition of the atmosphere is affected by burning fossil fuels. Well, hopefully you know that the complete combustion of fossil fuels produces carbon dioxide and water. And remember, complete combustion is when there's plentiful oxygen. So yeah, in this example, I'm showing methane, which is a natural gas, burning in oxygen, lots of oxygen, to produce carbon dioxide and water. If we were to balance it, we'd have a 2 in front of H2O. We've now got 4 oxygens on the right-hand side, which is why we need a 2 here. But in terms of describing the composition of the atmosphere, you're going to say that there is decreased oxygen, because obviously that's used up in combustion, and increased carbon dioxide and water vapour. That noise, if you can hear it, is my cat like licking her lips or something. C. The graphs in figure 1 and figure 2 show the concentration of carbon dioxide in the atmosphere and the mean global temperature between 1960 and 2000. So obviously, as years have gone by, the concentration of carbon dioxide has increased, as has the mean global temperature. Explain whether these graphs provide evidence that an increase in carbon dioxide is causing the Earth's temperature to rise. By the way, with this question, you can argue it either way. You could say yes, it does provide evidence, or you could say no, it doesn't. I'm going to go with yes because I think that's easier. So I'm going to first of all make the statement that as the concentration of carbon dioxide increases, so does the mean global temperature, and that's according to the graphs. This therefore provides evidence that an increase in carbon dioxide is causing the Earth's temperature to rise. Which of these pairs of gases are both greenhouse gases? So here, before I've looked at the options, I'm going to list my greenhouse gases. You do need to know this. Carbon dioxide, water vapour, methane. So where can we see this combination? Well, D. 2. Magnesium and calcium are in group 2 of the periodic table. They are less reactive than the metals in group 1. Calcium reacts with water to form calcium hydroxide and hydrogen, according to this equation. Describe what would be seen when a piece of calcium is dropped into a container of water. It's worth 2 marks, and we need to give at least 2 observations. So hopefully your teacher might have done this at school, and you'll know that the calcium moves around on the surface of the water. It also gets smaller in size. And crucially, there's lots of fizzing, which is actually, if you look at the balanced symbol equation, it's actually hydrogen being produced. So I've given more than 2 things there, but sometimes your answers aren't quite strong enough, so it's worth giving more here to ensure that you get 2 marks. Magnesium reacts very slowly with cold water, but reacts faster with steam, and forms magnesium oxide and hydrogen. Write the balanced equation for the reaction between magnesium and steam. This is nice, they've basically told us what all the formulae are. We've got magnesium reacting with steam to produce magnesium oxide and hydrogen. So magnesium, as you can see from the periodic table, is Mg. Hydrogen, the only difficult thing to remember here is that it is diatomic, which means it exists as 2 atoms together, so a molecule. You could have also seen that up here. It gives you lots of information in the question. So let's just write that out. Magnesium plus steam produces magnesium oxide plus hydrogen. And now you need to check if it's balanced, and yes, it is. The electronic configurations of magnesium and calcium are magnesium 282, calcium 2882. When magnesium and calcium react with water, they form positive ions. So hopefully you know that's because they lose these final 2 electrons here. Suggest an explanation in terms of their electronic configurations why calcium is more reactive than magnesium. So if we have a quick look at their electronic configurations, just because I want you to see why it's this way. Kitten, stop licking, it sounds really gross. That's magnesium. Oh no, it's going to be a huge mess. I'm not going to bother filling in all those electrons. The only thing I want you to notice here is that calcium is much bigger, which means the attraction of these outer shell electrons up here is weaker to the nucleus, because quite simply they're further away, which means it's far easier for them to be lost during a reaction, and that explains why calcium is more reactive. So let's start by saying the calcium atom is bigger than the magnesium one. Now we need to chat about the electrons. This means that the outer shell electrons are further from the nucleus and less tightly attracted. They are more easily lost in a chemical reaction, hence why it's more reactive. Stop licking. People don't want to hear it, Lyra. A sample of calcium, that's my pen. A sample of calcium bromide contains 0.2 grams of calcium and 0.8 grams of bromine by mass. Calculate the empirical formula of calcium bromide. I love these questions. So we're going to use my table format to do this because I love using this. So mass, MR, number of moles. Look at how I'm setting the question up. We need this formula triangle, which states that mass is number of moles multiplied by the MR. We've been given the mass in the question, so that's 0.2 grams of calcium, 0.8 grams of bromine. Using these 2 numbers now, we have our MRs. So calcium is 40, bromine is 80. And then in order to work out number of moles, hopefully you can see the number of moles, according to this formula triangle, is mass divided by MR. So for calcium, quite simply do 0.2 divided by 40 to get 0.05. For bromine, 0.8 divided by 80 is 0.01. And then write an instruction to yourself. Divide by smallest number to get ratio, because you need it to be a ratio at the end. Obviously 0.005 is smaller than 0.01, so we're going to divide both sides by that number to get 1 to 2, and therefore this is our formula. Make sure you take the question to its completion. 3. Crude oil is a mixture of hydrocarbons. It can be separated into fractions Which of these mixtures show formulae of substances that could be in the gaseous fraction of crude oil? So you're looking for alkanes here. Remember, their general formula is CnH2n plus 2. So, for example, looking at the first three alkanes, this is their formula, C2H6, C3H8. And let's add butane for completeness sake. Okay, so we're looking for these formulae in this list, and when you've identified them, then you know that's the correct answer. And as you look down the list, hopefully you can see that that is C. State which oil well contains the greatest combined total of diesel oil and fuel oil. So have a look down these columns and basically add them together, these two numbers, and see which one is the highest. So obviously this one is 33, this one is 38, this one is 46, so it's oil well C. State which oil well produces a crude oil containing the highest percentage of high boiling point fractions. So in terms of the highest boiling point fraction, hopefully you know that this is bitumen. So refinery gases at the other end have the lowest boiling point, bitumen has the highest, so we're looking at this part of the table. So looking along the bitumen column, which one has the most amount of bitumen? Well, that's oil well A, because it has 58. Fractions of crude oil contain alkanes. A sample of decane, C10H22, cracked using the apparatus shown in figure 4. So we've got our ceramic wall soaked in decane. Porous pot is being heated, and we know that the decane is going to produce a gas, which is ethene over here. Explain how ethene is produced using the apparatus in figure 4. It's worth 3 marks. So first of all, let's state that when decane is heated, it turns into a gas. Because this is effectively a cracking process, the decane breaks down into shorter fractions when it hits. And remember, a fraction is a group of substances with similar boiling points. One molecule of decane produced 2 moles of propene, C3H6, and 1 molecule of product Z. What is the formula of product Z? I'm just going to write it out here again so you can see it more clearly. Lyra! So work out how many carbons you have here. Well, you have 6. The number of hydrogens is 12. And then over here, we've got 10 carbons. So what is the difference in the amount of carbons you have on the right-hand side compared with the left-hand side? Well, it's 4, so that's why it's C4. We've got 12 hydrogens on the right-hand side, 22 on the left-hand side, so obviously we need 10 here. And that's why B is the correct answer. When decane undergoes complete combustion, a mixture of carbon dioxide and water is formed. Complete the balanced equation for this reaction. When you're given complete combustion equations, or even incomplete combustions, you must balance the carbons first. So what that means is working out how many carbons you have here. Well, it's 20, because of that big number multiplied by 10, which means we need 20 on the right-hand side. So secondly, we want to balance the hydrogens. Now, on the left-hand side, we have 2 lots of 22, so we have 44 hydrogens. So we need 44 hydrogens on the right-hand side, which is why I'm going to put the figure 22 here. And then lastly, you want to balance the oxygens. So count up the amount of oxygen on the right-hand side. So that's going to be 40 oxygens here, 22 here, so that makes 62. And therefore, how many oxygens do you need on the left-hand side? Well, 62, so we're going to put 31 there. Question 4. Alkanes and alkenes are hydrocarbons. The structure of a molecule of butane is shown. Which of the following is the empirical formula for butane? So the way in which you work this out is by using this displayed formula to give you the molecular formula. So count up the number of carbons, well there's 4 of them. How many hydrogens? Well there's 10. So in order to work out the empirical formula, you're looking for the simplest ratio of atoms of each element. So literally just cancel this down. So both of these numbers are divisible by 2. So it becomes C2H5. C is therefore the answer. Figure 5 shows some information about the alkenes, ethene and propene. Complete the table. The structure of propene must show all covalent bonds. So the molecular formula of ethene, just say what you see. So it's C2H4. Propene, well, it's unsaturated, which is why it has a double bond. And the only thing to notice here, that each carbon atom should have 4 bonds. That is key. So I'm going to count those 3 for you. So hopefully you can see for this carbon here, has 1, 2, 3, 4. For the middle carbon, it has 1, 2, 3, 4. For the final carbon, it has 1, 2, 3, 4. So that is correct. But let's just delete that so you can see the actual structure. C. Butene reacts with steam to produce butanol, which is an alcohol. Calculate the maximum mass of butanol that can be produced when 1.4 kilograms of butene reacts with excess steam. Okay, table time. So write out that balanced symbol equation again. That's key. It's not very helpful just having it by itself at the top. As you can see, I've got the same table headings and the same formula triangle. Reread the question. You're looking for the maximum mass of butanol. So that is this value here. And we know that we've got 1.4 kilos of C4H8. Don't worry about changing the units because the final answer will be in the same unit, so it's not a problem. Now you want to calculate the MR of C4H8, and we've been given that here in the question, so let's just pop that in as being 56. We might as well work out the MR of butanol, so we need to do 12 times 4 plus 1 times 9 plus 16 plus 1 to get a value which is 74. And now number of moles, you can see from the formula triangle, is mass divided by MR. So let's do that here. So number of moles of C4H8 is 1.4 divided by 56, which equals 0.025. Now look at the mole connection. Have a look to see if there are any big numbers in front of the formulae. There aren't, so you're allowed to copy this number of moles across directly. So now you have the number of moles and the MR of butanol. Hopefully you can now see that we have enough information to calculate the mass. So to work out the mass of butanol, we do number of moles times MR. We've calculated the number of moles as being 0.025. The MR we've just done is 74. And when you pop that into your calculator, you get a value which is 1.85, and that's in kilograms. What type of reaction takes place between butene and steam? Well, because you're adding steam to butene, as you can see in the equation up here, it's an addition reaction. So A is the correct answer here. D. A sample of each of 3 hydrocarbons, X, Y, and Z, was shaken with bromine water. Bromine water is orange coloured. The results are X orange mixture becomes colourless, Y orange mixture becomes colourless, Z mixture remains orange. Using the results, comment on the structures of hydrocarbons X, Y, and Z. Hopefully you know that adding bromine water to a particular hydrocarbon is proving that it's an alkene. So if it goes from orange to colourless, you have an alkene, which means you have a unsaturated hydrocarbon. Let's prove why. So if we take ethene, for example, we add it to bromine water, that double bond breaks and the bromine just adds itself. So hopefully you can see that although this part, the reactants, were orange due to the bromine water, because that bromine water has effectively disappeared, that's why it goes colourless. Which means X, because it goes colourless, Y, because it goes colourless, they both must be unsaturated. Because Z remains orange, it's most likely that it's an alkane, because if you take methane, for example, hopefully you can see here that we've just got a substitution reaction going on, and the whole substance will remain orange. So let's just make those comments. So X and Y are both alkenes. This means that they are unsaturated, as they contain C double bond C. So hopefully you see I'm writing a very full answer here. Z is an alkane. It is saturated, which means it only contains C single bond C. 5. Qualitative, did I pronounce that right? Tests are used to identify ions. A student carries out a flame test on an unknown solid. A red flame is seen. The student concludes that the solid is lithium carbonate. Explain why this conclusion is not justified. I'm happy with her thinking, or him, thinking that it is lithium because the red flame has been seen, and that's what you see. So yes, it's lithium. However, we haven't done any testing to prove that it's carbonate. We haven't used any acid, done any fizzing, captured the gas to prove that it's carbon dioxide. So quite frankly, it could be anything. So it's definitely not carbonate necessarily. So let's start by saying red flame indicates lithium. However, no test has been done to prove the presence of carbonate ions. It could be sulfate, it could be nitrate, it could be chloride, bromide, iodide. So yeah, that's 2 marks. Just so you know, you could also said that the lithium hasn't been proven because there are other metal ions that go red in a flame, so calcium, for example. But I have actually written 2 things here that give us 2 marks. B. The following tests were carried out on a substance containing 2 ions. A flame test on the solid substance produced a yellow colour. Dilute hydrochloric acid was added to the solution of the substance, followed by a few drops of barium chloride solution. A white precipitate was formed. Give the name and formula of the substance. So let's start by looking at the yellow colour. Hopefully you've learnt that a yellow flame indicates sodium. So sodium ions, so that's Na+. The dilute hydrochloric acid being added, followed by barium chloride. Hopefully you recognise this as being the test for sulfate ions. And when you get a white precipitate, it means that you do indeed have sulfate. So the formula of the sulfate ions is SO4 2-. The name of the substance is obviously sodium sulfate. We're trying to form a formula from sulfate ions and sodium. Hopefully you can see that those charges don't balance. You could obviously use the drag and drop method that lots of teachers use. Personally, I prefer to have a look and work it out logically. You need twice as many sodiums as sulfate ions, which is why the formula is Na2SO4. C. The test for chloride ions was carried out on a solution. Dilute nitric acid was added to the solution, followed by a few drops of silver nitrate. A white precipitate was formed. Well, yep, that's good. That's what I would expect for chloride ions. Why is it necessary to add dilute nitric acid in this test? Hopefully you know that the reason they add acid at the beginning is to remove any carbonate ions which interfere. And this is the exact sort of thing that's in my revision guide. Because I've spent so long going through past papers, I can see the exact weird questions that pop up that people don't necessarily know about. So that's what my revision guide's all about, perfect answers. So that's why C is the correct answer here. D. Sodium hydroxide solution is used to identify some cations present in compounds. Remember that these are positively charged. Why has that written it like that? Sodium hydroxide solution is warmed with a solution of ammonium ions. Ammonia gas is given off. Describe the test to show the gas is ammonia. Again, this is one of my revision guide answers. The easiest way, you could have written loads. You can see they've given you 4 lines, but the easiest thing to do here is state that damp red litmus paper turns blue. And believe it or not, that's everything you need to score those 2 marks. I love being concise, and this is no exception. Sodium hydroxide solution is also used to distinguish between iron 2 ions, Fe2+, and iron 3 ions, Fe3+. You are given a solution containing iron 2 ions and another solution containing iron 3 ions. Describe what is seen when sodium hydroxide solution is added to each of these solutions. You need to learn here that it's a precipitation reaction and that the colours are as follows. Iron 2 is green, iron 3 is brown. So Fe2+ produces a green precipitate. And you need both of those words to get the mark. Fe3+ produces a brown precipitate. So doing well in chemistry is all about being very precise. You can't really waffle here, you just need to know the facts. Fe3+ reacts with hydroxide ions in solution to form iron 3 hydroxide. Complete the ionic equation for this reaction. So here are our 2 ions. Hopefully you can see that you need 3 lots of hydroxide ions to balance that Fe3+. We need to include brackets so that the 3 applies to everything. 6. This question is about the properties of metals. Figure 6 shows some properties of steel and Kevlar. So we've got density, relative strength, flexibility, and resistance to corrosion. Body armour, such as bulletproof vests, could be manufactured using either of these materials. Explain 2 reasons why Kevlar is preferred to steel as the material for body armour. So only pick 2, and you need to explain. So state one of them and then say why it's good. So let's first of all talk about the strength. Kevlar is stronger than steel. And what is body armour used for? Well, it's to stop you getting shot or stabbed, so it is less likely to be penetrated. Resistance to corrosion, well, we can see that Kevlar is high, which means it's not going to rust in the way that steel would. So Kevlar has that's a weird A, resistance to corrosion and therefore will last longer. So hopefully you can see how we've explained each of the 2 points. You could have used either of the other 2 as well, by the way. The use of nanoparticles has increased in recent years. The length of one side of a cube of silver is 2 centimetres, as shown in figure 7. Calculate the surface area to volume ratio of this cube of silver. So, a bit of maths now, which is, for me, nice. Hope you guys like maths. So we are looking first of all for the surface area. So let's work out the surface area of one side. So it's 2, because it's a cube, all the sides will be the same. So that's 2 by 2. And then count the number of sides. So as you look at it, hopefully you can see, imagine it in 3D, that it has 1, 2, 3, 4, 5, 6 sides. So that's surface area done. Now the volume. In order to work out a volume, you need to do, volume is length times base times height, which is effectively 2 by 2 by 2. So let's work out both of these sums. So 2 times 2 is 4. Don't know why I forgot that multiply sign. Times 6 is 24. 2 times 2 is 4, times 2 is 8. And then because it's a ratio, we want one of these numbers to equal 1. So divide by the smallest number, which in this case is 8, to get 1 to 3. So our final answer here is 3 to 1, because make sure it lines up that it's surface area to volume. Suggest an explanation of why a given mass of silver is more effective as a catalyst when used as nanoparticles rather than powdered form. hopefully you know that nanoparticles are extremely small, which means by being smaller, they have a much larger surface area. So let's write that. Silver nanoparticles have a greater surface area and it's actually to volume ratio compared with the powdered form. And then it's a rates of reaction question really, so collision theory, this means that there is an increased frequency of collisions. So in a given time, more molecules can react. 7. A student investigated the rate of reaction between dilute hydrochloric acid and marble chips, calcium carbonate. Calcium chloride, carbon dioxide and water are formed. Complete and balance the equation for the reaction. So we've been given the hydrochloric acid formula and the calcium carbonate formula. You do need to learn that carbon dioxide is CO2. Water as well is fairly straightforward, H2O, you must know these. Let's just work out the formula of calcium chloride. Calcium is in group 2, so its formula is 2+. Chlorine is in group 7. It's a non-metal, so to work out the charge on its ion, first of all, it will always be negative, and to work out the number on that charge, you need to do 8 minus 7, so minus its group number, to get Cl-. As you can see, calcium is more positively charged than chloride is negatively charged, so we need 2 chloride ions, which is why the formula is CaCl2. Remember, the metal should always come first. Let's check to see if it's balanced. Well, I can see straight away that the chlorides aren't balanced. I don't understand why they haven't given us enough space here, but to balance it, you need to put a 2 here. Have a look back, check that the carbons are balanced, that the oxygens are balanced, and you will see that they are. B. The student investigated the rate by using different sizes of marble chips. In their investigation, the same mass of marble chips was used in each experiment. The volume of gas given off was measured. The graph in figure 8 shows the results. State how the graph shows that line B gives the results for the larger marble chips. Because B has larger marble chips, it has a smaller surface area, which means that the rate of reaction will decrease. And that will be seen by a less steep gradient on the graph line. So let's write that now. Line B has a less steep gradient, indicating the lower rate of reaction. A tangent has been drawn on line A. Calculate the rate of reaction at this point. Here's the tangent. So we're looking, because it's the gradient, we need change in y over x. Have a look along the y-axis, so it's between 30 and 90, which is 60. X, we can see, if you look carefully, that it goes up to 72. So do 60 divided by 72 to get 0.833 to 3 sig fig. During any reaction, reactants are used up and the rate of reaction decreases. Explain in terms of particles why the rate of reaction decreases. So if I draw here, you have reacting particles and they collide with each other to form the product, and effectively those particles get taken out of the reaction. Then these particles collide, they get removed. So can you see that over time the number of reactant particles decreases? So let's write that here. There are fewer reactant particles. This means that the concentration of reactants decreases. And then because it's a rates of reaction question, you always need to talk about frequency of collisions. There will be a decrease in the frequency of collisions between reactant particles. D. The decomposition of hydrogen peroxide is catalyzed by adding a small amount of manganese oxide. Which of these graphs shows the massive catalyst as the reaction takes place? To be able to answer this question, you need to know that a catalyst speeds up the rate of reaction without being used up. That means that its mass is constant. So as you look down the graphs, you're looking for the one where the mass remains the same. It's this one, so that's C. Two gases X and Y react to give a gaseous product Z. The reaction is carried out under two different sets of conditions in experiments 1 and 2, as shown in figure 9. Explain why it is not possible to predict what the rate of experiment 2 will be compared with experiment 1. So when you increase the temperature of a reaction, the rate of reaction increases, and that's due to the particles having greater kinetic energy. When you increase the pressure of a reaction, again you increase the rate of reaction because the particles collide more often. Now, because the decrease in temperature will cause a decrease in the rate of reaction, and the increase in pressure will cause an increase in the rate of reaction, these changes have opposite effects, and clearly it's not possible to see which of these changes has a greater effect. The elements chlorine, bromine and iodine are part of group 7 in the periodic table. The appearances of chlorine, bromine and iodine at room temperatures are shown in figure 10. So chlorine, which if you use your periodic table you'll see is at the top of the group, is a green gas. Bromine is a liquid, iodine is a solid, and the colour gets darker as you descend the group. Astatine is the element below iodine in group 7. Predict the appearance of astatine. I've just said that the colours get darker as you go down the group, and notice the state of matter. You've got to mention a state of matter to ensure you get the full mark. So go black solid here. B. The order of reactivity of chlorine, bromine and iodine can be determined by carrying out displacement reactions. Explain how displacement reactions can be used to show the reactivity of these elements. 6 marks, you've got to get organised. So the best thing to do here is first of all state the order of reactivity, and as you look at the periodic table, as you descend group 7, the elements get less reactive. So iodine will be the least reactive, whilst chlorine is the most reactive. So order of reactivity states that chlorine is more reactive than bromine, which is in turn more reactive than iodine. If you don't like using these crocodile greater less than signs, obviously feel free to write it out in English. Now we need to talk about the actual displacement reactions, and the easiest thing to do here is react each of them in turn with a particular substance, which is potassium iodide. So displacement reactions. So react chlorine with potassium iodide. Chlorine is more reactive than iodine and therefore displaces it. And we can write some equations to show this because it's chemistry after all. So chlorine, it's diatomic, plus potassium iodide. So the chlorine displaces the iodine, so it becomes potassium chloride plus iodine. Double check to see if it needs balancing. Yeah, we need 2's in front of the potassium iodide and the potassium chloride. It's worth pointing out the colour changes. So you want to say that the solution turns brown. And now it's just a matter of repeating that last paragraph, but taking bromine. So react bromine, you can see I'm writing the exact same words, just swapping chlorine for bromine with potassium iodide. Bromine is more reactive than iodine and therefore displaces it. Okay, an equation again, it's very similar to the one above, so I'm just going to go straight out and write it out. And again, the solution turns brown. So hopefully you can see from these first two reactions we've proven that iodine is the least reactive. Now it's a matter of proving between chlorine and bromine which is more reactive. So this time we need to take a different salt. we're going to take potassium chlorine. It doesn't really matter, there's loads of ways of answering this question, but this is how I'm going to do it. So this time we're going to react bromine with potassium chloride. Bromine is less reactive than chlorine, and therefore no displacement reaction can take place. So effectively we are providing a recipe, a method, in order to prove that chlorine is more reactive than bromine, which is more reactive than iodine, and that's what we've done here, including some very important key equations. Obviously there's no equation for the last part because no reaction has taken place. When iron wool is heated in bromine vapour, it reacts to form iron bromide. In an experiment, 5.6 grams of iron reacted exactly with 24 grams of bromine. Determine, using this information, the balanced equation for the reaction between iron and bromine. You must show your working. So hopefully you can see we're reacting iron and bromine. Bromine, we've been told, is diatomic, and we're going to produce iron bromide, but we don't know the formula of this. So how can we write a balanced symbol equation for it if we don't know its formula? And we're going to have to use these numbers up here to work out its formula. So actually we're being asked to find the empirical formula first of all. So that's what we're going to do. So we've already done it actually above. So using the same methodology, same table format, same triangle. So the masses being given in the question are 24 grams of bromine, 5.6 grams of iron. We've got an MR of 80, which we're told here for bromine, and 56 for iron. To work out the number of moles, simply do mass divided by MR. So that's 24 divided by 80 for bromine to get 0.3. 5.6 divided by 56 is 0.1. Previously we divided by the smallest number, so we're going to do that again. 0.1 is smaller than 0.3, so we're dividing both by 0.1 to get 1 and 3. So our ratio is 3 to 1. Make sure when you write your formula that the metal comes first. So it's FeBr3. And now we're ready to finally answer the question. So we want the balanced equation, so that's iron plus bromine forms iron bromide. Let's balance it now. We've got too many BRs on the right hand side. By the way, if you can't inspect an equation to balance it, you want to watch my video on balancing equation, which takes you through step by step showing you how to do this, and it works every single time. But I'm going to do it by inspection because this is an exam talk through and I can see that I need these numbers. So we've got 2 irons on the left hand side, 2 on the right, 6 bromines on the left hand side and 6 on the right. So it's done. When iron reacts with bromine, bromide ions are formed. Explain the type of reaction bromine atoms undergo when they are converted to bromide ions. So we're taking an atom, we're turning it into an ion. So in order to do that, you can see it's gained negativity, which means it's gained electrons. Notice that because bromine is diatomic, we need 2s here in order to make it make sense. So the type of reaction, hopefully you can see that we've gained electrons. According to oil rig, oxidation is loss of electrons, whereas reduction is gain of electrons. And because it's gained electrons, reduction has taken place. Nine. A student carried out an experiment to prove that candle wax, a hydrocarbon, produces carbon dioxide and water vapour when it burns. The equipment used is shown in figure 11. So we've got candle burning attached to a funnel. There's lime water, so that will be to do with any carbon dioxide that gets produced. We've got a second boiling tube which is sitting in ice, and then we have a pump. The gas produced from the burning candle is drawn through the apparatus. The lime water turned milky, showing that carbon dioxide has been formed. a small amount of colourless liquid condensed in boiling tube X. The student claimed that this proved that burning candle wax produced water. The teacher said that the apparatus had been set up incorrectly and therefore this conclusion about water was not valid. Explain how the student could modify the equipment to prove that water is produced by the burning candle wax. The real issue here is not knowing in boiling tube X what the substance is, if it's water, or because it's attached to the tube in front of it which contains lime water. Clearly it could have been lime water. So basically you need to reverse the order of the boiling tubes to ensure that whatever comes off the candle gets condensed in boiling tube X, and then after that the gas goes through, proving that it's carbon dioxide in the lime water. So we're going to write reverse the boiling tubes so that the gas passes through the tube in ice water first. This would mean that any liquid which condenses must have come from the burning wax and not the lime water. That's quite a long answer, to be fair, for 2 marks. It's a bit annoying, really. B. Polymers are addition or condensation polymers. Polymers can be formed by using the monomers shown in figure 12. So we have chloroethene, ethane 1,2-diol, and ethane dioic acid. So this here is a carboxylic acid. As always, I'm always making notes. This is an alcohol. Explain using appropriate monomers from figure 12 how different polymers can be formed. Oh, this is quite a tricky question. So first of all, let's state what a polymer is. Polymers are large molecules formed from many small molecules, monomers. These are called joining together. So if you have a look, first of all, let's try and work out the type of polymerization that we could do. Because this is unsaturated, we can therefore do addition polymerization, which is basically when you break the double bond and add lots of them together. So let's do that now. So chloroethene monomers can join together in addition polymerization to form polychloroethene. I hope you can see how I managed to form its name. So if we take its structure, which looks like this, we've been given it in the table. In order to show addition polymerization, we create square brackets, we break that double bond, we elongate the bonds outside, and then just redraw the atoms and write an N, and that is done. Okay, I'm really running out of space here. I don't know how they expected us to do this. Next up, we're going to show condensation polymerization, which is when you have a diol reacting with a dioic acid. So we're going to take these two now and show what happens. And I'm just going to write here what a condensation polymerization reaction is, and it's where water is lost. So let's take our two monomers. Again, they're in the table. This is where the water molecule will be lost from, and then just stick together those two monomers to form the polymer. This is such a hard question, seriously guys. This is such a hard question, seriously guys. You have to be so careful with it. And this is actually polyester. C. An alcohol A with molecular formula C2H5OH is oxidized to a compound B with molecular formula C2H4O2. Compound B is not an alcohol and is a member of another homologous series. State the name of this homologous series. So we've got our alcohol and it's being oxidized, and you need to know that when alcohols are oxidized, they produce carboxylic acids. So this is ethanol here, so it will actually produce ethanoic acid. A homologous series is just a formal name for a family of compounds. So I'm going to write that here as carboxylic acids. Draw the structure of a molecule of compound A and a molecule of compound B, showing all covalent bonds. This is quite nice. The ethanol, they've actually kind of shown you the order. So we have 2 carbons, 5 hydrogens, and then the functional group of the alcohol is OH. So that's why it looks like this. Compound B, ethanoic acid. So we've got 2 carbons because it's ethan. The functional group of a carboxylic acid is this. And then we need to fill up with hydrogens. This is very advanced chemistry, guys. And then just double check that you have the same molecular formula, C2H4O2. Yes, we do. How they've written it here is disgusting. It doesn't really give you any indication of the shape of the molecule, which is why it's so important that you know what carboxylic acids look like and that they have this functional group. Really hard. Question 10. Each of these substances forms ions in solution. 1 mole of the following substances is dissolved in 1 decimeters cubed of water. Which solution contains the greatest number of ions? Let's just count the ions present then. So ammonium sulfate, that's NH4+. We've been told there are 2 of them. And we've got a single SO42-. So that means there's 3 ions altogether. 1, 2, 3. Iron chloride now, we've got Fe3+, 3 chloride ions. So that's 4. Magnesium nitrate, we've got 1 Mg2+, 2 NO3-, so that's 3. KBr is simply K+, Br-, so that's 2. 4 is the largest number here, which is why B is the answer. When sodium hydroxide solution is neutralized with an acid, there is a temperature change. The student is given dilute hydrochloric acid and dilute ethanoic acid of the same concentration. Devise a plan to compare the temperature changes produced when sodium hydroxide solution is neutralized with 2 of these acids, with each of these 2 acids. And you might have seen this at school. You have like a polystyrene cup with a lid to prevent heat loss, a thermometer, the solutions are added, you measure the temperature change. So we're basically going to write that now. So start by saying you measure a known volume of sodium hydroxide solution. Next up, add the same volume of HCl. Stir, and that's to mix up the contents. Measure the initial and final temperatures. And clearly we need to repeat using ethanoic acid. C. Hydrogen reacts with chlorine to form hydrogen chloride according to this equation. The reaction is exothermic. Draw and label the reaction profile diagram for this reaction, identifying the activation energy. Exothermic means that delta H, so change in heat energy, is negative, which means the products have to sit at a lower level than the reactants because this needs to go down. So that means negative. Then you just need to label the reactants. So the first line is the reactants, which is why I'm just copying them directly from the equation I've been given. And the second line is the products. So again, just use your equation to help you with this. And then lastly, you want to label the activation energy because they've asked you for that. So I'm actually going to rub out this line because it will make it messy otherwise, and just show it as a hump. And this is the activation energy because remember, it's the minimum amount of energy required for the reaction to occur. So do go back and check that you have drawn and labelled both the profile diagram and the activation energy, because it sucks to lose marks that you haven't spotted. The energies of some bonds are shown in figure 13. Hydrogen reacts with chlorine to form hydrogen chloride. Calculate the energy change for the reaction of 1 mole of hydrogen gas with 1 mole of chlorine gas to form 2 moles of hydrogen chloride gas. Okay, so basically it's a way of asking you to work out the bond enthalpies here. So let's first of all start with the reactants. And I like to draw out the structural formulae of the reactants so I can see the bonds. Here's the product. And as you can see, we have 1 lot of hydrogen bonds on the left-hand side, so that's 1 times 4, 3, 6. We've got 1 lot of chlorine, so that's 1 lot of 2, 4, 3. You want to add together those numbers Then let's do the same for the products. So we've seen a 2, so we need to do 2 lots of hydrogen chloride. So 2 times 432 to get 864. And then the final thing you need to do to work out the energy change is do the reactants minus the products. And when you pop that into your calculator, you'll get minus 185 kJ mole to the minus 1. This is crucial, the minus. It's what you would expect because it's an exothermic reaction, but make sure you have that sign. Wow, what a beast of a paper. Really hope you found that helpful, guys. Those last few questions were pretty damn tricky. Don't forget to like and sub and tell your friends about my channel if you want to see more like this.